Okay, this is going to be a continuation of the notes that we had started. This is part 1. I went ahead and put part 1 and we left off at the very end with this last little example or notes about the parent function. Your homework is to watch both of these videos and take notes on part 1 and part 2 and to submit the exit slip and summary as a grade. Okay, so if I was you, I would write on the back of your page, but since I wrote in the Sharpie, it bled through, so I'm going to go ahead and just do it on a second sheet of paper. That second sheet of paper should read something like this, part 2. If you want to pause this and copy it down, you can. Part 2 is going to be your practice problems. We're going to identify the key characteristics of each function. Each function is a transformation of the parent function, but you're still going to figure out the same things. The vertex, the domain and range, whether it's a maximum or minimum vertex, the range, the concavity, the intercepts, symmetry. We're going to add transformations, and of course I want you to do your table and graph for each function. If you look at number 1, this would be number 1. If x is equal to, you have to figure out what your input's going to be, and then you substitute it into your equation. So let's start with, let's start with -4. So if x is equal to -4 and I plug in -4 wherever I see an x, what is -4 plus 2? -4 plus 2 is a -2, but the absolute value of -2 is just +2. Let's say our input is -3. What is -3 plus 2? That is equal to -1, but the absolute value of -1 is just 1. Do the same thing for an input of -2. If I let x be equal to -2, -2 plus 2 is 0. The absolute value of 0 is 0. Then you're going to do the same thing for -1. If I let x be equal to -1, -1 plus 2 is equal to +1. The absolute value of +1 is 1. And you keep going, okay? So go on and so on and so forth. So 0 plus 2 is 2. The absolute value of 2 is 2. 1 plus 2 is 3. The absolute value of 3 is 3. 2 plus 2 is 4. The absolute value of 4 is 4. So we're going to plot our points. When x is equal to -4, y is equal to +2. I'm going to go to the left 4 and up 2. When x is equal to -3, y is equal to 1. When x is equal to -2, y is equal to 0. When x is equal to -1, y is equal to 1. When x is equal to 0, y is equal to 2. And then finally, when y is equal to 1, y is equal to 3. When x is equal to 1, y is equal to 3, and so on. Okay, I kind of ran out of space, but you get the idea. Increasing from the vertex to the right, and then also pointing up from the vertex to the left. Okay, so you have to figure out what are the key characteristics of this function. Well, what's the vertex? The vertex is here, and the vertex is located at -2, 0. Is this a maximum or minimum? Is it the lowest point or the highest point on the graph? It is the lowest point on the graph, so it's a minimum. The domain is always all real numbers. Okay, so in this case, we're going to go from -infinity to +infinity, or for all x values greater than -infinity, or you can see it for all x values less than +infinity. So the way to say it is all x values between -infinity and +infinity. These are going forever in both directions, forever to the left and forever to the right. Your range, remember, depends on the y coordinate of the vertex. So in this case, your vertex is -2, 0, your y coordinate is 0. So your graph is going from 0 to, is it pointing up or is your graph pointing down? Well, in this case, our graph opens up, so it's going up towards positive infinity. We never really equal to infinity, so it's going to be a parentheses, but we are equal to 0. There is a closed dot at 0 when y is equal to 0, and if you look at your table, the point actually exists at -2, 0. Another way to write this is all y values greater than 0, right? All y values that are greater than 0. Or you could say the y values that are less than positive infinity, but bigger than 0, or in between 0 and positive infinity. Okay, it has an x-intercept and a y-intercept, but they're in different locations. So the x-intercept occurs at x equals to -2, but the y-intercept, where does it cross the y-axis? When y is equal to 2. Okay, so the ordered pairs are different. The x-intercept occurs at -2, 0. The y-intercept occurs at 0, +2. Okay, next question, is it symmetric? Does it look the same on both sides of the y-axis? If I were to fold this paper over or copy this part to that side, do they look the same? The answer is no. And then, is it symmetric about the x-axis? Is the section up here on the top, if I reflected it over the x-axis, does it look the same? And it doesn't. So there is no symmetry about the x or the y-axis. Okay, if you look at your original function, which was absolute value of x, you want to compare that to your new function, which you just graphed. So remember, our absolute value function, parent function, always starts at the origin. And if you compare it to practice problem number 1, how did the graph change? How did it go from starting at 0, 0 to your vertex being at -2, 0? How would you describe that transformation? Is it a vertical shift or a horizontal shift? Okay, the correct answer is horizontal. Horizontal shift, which direction? Is it to the left or to the right? That's right, it's going to the left. And then how many units did it move to the left from the parent function? Well, it moved 2 units to the left. Okay, so this is how I want you to do your practice problems. I want you to go ahead and pause it so that you can copy everything down for this problem. And then I also want you to copy down number 2. This is going to be part of your turn. I will not be giving you the answers to this on this video, but you will be doing that on your own. I'm going to go ahead and pause. Well, I'm going to let you copy this down, go ahead and solve it, and then I'm going to resume on to number 3. Okay, a really quick hint for number 2. Remember that you substitute in the x value into your absolute value function. What is the absolute value of -3? That's right, it's +3, and then you have to add 2. So what is 3 plus 2? 5. You do the same thing for -2. You substitute in -2 wherever you see an x, which gives you -2. The absolute value of -2 is a +2. 2 plus 2 is 4. Okay, so your ordered pair is -3, 5, -2, 4. You do the same thing for -1. The absolute value of -1 is 1. 1 plus 2 is 3. Okay, and so on. So make sure you check your table against mine and then fill out the rest of the key characteristics. Okay, so the next problem that we're going to do together, we're going to be doing the same type of information, okay? I just kind of shortened it a little bit. So if you're trying to find out the absolute value of -x plus 2, So let's do our table, x and y. If I start at -3, what is the absolute value of -3? Well, a +3. But the opposite of a +3 is actually -3. And what's -3 plus 2? -1. Okay, the absolute value, I guess if I write it down, the absolute value of -2 is a +2, but the opposite of +2 is 2, and 2 plus 2 is 4. If I have x is equal to, sorry, my bad. The absolute value of -2 is a +2. The opposite of +2 is -2. -2 plus 2 is 0. Okay, if I plug in -1 here, what is the absolute value of -1? It is a +1. The opposite of +1 is actually -1. So -1 plus 2 is equal to 1. Same thing for 0. The opposite of 0 is just 0, so 0 plus 2 is 2. Alright, so I'm going to go ahead and graph these points. -3, -1, 1, 2, 3. The next one is -2, 0. Next one is -1, 1. Next one is 0, 2, next ordered pair. Okay, and I think we probably should have picked another number over here. But you already get the hang of this, and you know that it's going to go forever in both directions. Okay, I should have gone through here. So bad. Bad function. This is why you shouldn't be using pen. Okay, so here's your function. If you notice the difference or the change from the parent function, what changes do you see? Well, instead of pointing up, it's pointing down, right? And instead of starting at the origin, it's shifted a couple of units to the left. Okay, so let's talk about the vertex. What is the vertex for this function? The vertex for your function is here, which occurs at -2, 0. Is this a maximum or a minimum? This is a maximum. It is the highest point on the graph. Your domain is always all real numbers. It's always going to be -infinity to +infinity for any absolute value function. The range depends on your vertex. So your vertex, the y-coordinate of your vertex is 0. So I have to figure out, is my graph pointing down or is it pointing up? The correct answer is down. Since it is pointing down, that means it's going down to -infinity. -infinity is smaller than 0, so we're going to put that first. We can never really be equal to infinity, so I'm going to put parentheses. And on the 0, 0 is part of the graph. It is a closed circle, and it's also included in your table. So I'm going to put a bracket on this 0. We are talking about all the y values that are greater than -infinity, but smaller than 0. So all the y values between -infinity and 0. It has an x-intercept. The x-intercept occurs here. That happens to be the same thing as the vertex. And then it also has a y-intercept, which occurs here at 0, +2. -2. Is it symmetric about the x-axis? If I fold